Okay, let's look at number 5. And we have to get all the information and graph this function. So we'll start with the f of x information. All right, so we have f of x is equal to x cubed over 3 minus x squared. So first we have the x-intercepts we get by setting the numerator equal to 0, and so that would be x equals 0. So 0, 0, that's going to be an x-intercept and a y-intercept. And then the asymptotes from setting the denominator equal to 0, so we see that the asymptotes occur at x equal plus or minus square root 3. Okay, so now we have the x-intercept and we have the asymptotes. Let's see, we still have to do the y-intercept. And we get the y-intercept by substituting x equals 0. And it turns out that this is 0, 0 as well. Okay. And finally, end behavior. And that'll be it for f of x. All right, so let's write as x goes to infinity, we're looking at x cubed over minus x squared. That's equal to minus x, and that'll go to negative infinity. And as x goes to negative infinity, minus x will go to positive infinity. So that means down on the right and up on the left. Okay, so that's all the information that we get from f of x, and we're going to go on to f prime of x. Now we're going to get information from f prime of x. So let's start by calculating f prime of x. We'll use the quotient rule. Okay, square that, square g, the denominator. Now place it up here. Derivative of numerator minus derivative of denominator times the numerator. Now all this, if we multiply out this numerator and simplify, here's what we get. Okay, here's what we get in simplified form. All right, now to do our plus minus analysis of f prime, we're going to put zeros of the numerator and denominator on the number line. All right, so from the numerator we have 0 and 3 and minus 3. And from the denominator we have square root 3 and minus square root 3. Now notice I have open circles here because those are zeros of the denominator of f of x. So the function does not exist at root 3 and minus root 3. So we're going to put square root symbols there. Open circles over there. And these are not going to be candidates for max-mins because these are vertical asymptotes. All right, let's do our plus minus analysis. Let's say we substitute in a 4. And here we're going to have minus 16, and here we have 16 minus 9, which is positive, minus 16 is negative. So that'll be, and the denominator is positive because it's squared. So that'll be negative. Okay, here let's say we put in a 2. Okay, so here we have minus 4, negative, and here we have 4 minus 9, that's another negative, so that would be positive. And again, the denominator we don't worry about because that's squared, that's positive. All right, let's put in a 1 here, and here we're going to have negative, and here also negative, so that'll be positive. And here let's put in a minus 1, and here we have negative, negative again, so again positive. And now let's say we put in minus 2, and here we have negative, and here we have 4 minus 9, another negative, 2 negatives, so again positive. And let's say we put in the minus 4, and here we have minus 16, and here we have 16 minus 9, so that's negative, positive, so that will be negative. All right, and what does this tell us? Well, this tells us that our function is decreasing in this interval and increasing here and increasing, 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 and decreasing here. So here at minus 3 we have a switch from decreasing to increasing, so that's a min. And at 3 we have a switch from increasing to decreasing, so that's a max. So we have a min at minus 3, f of minus 3, and a max at 3, f of 3. Okay, so here we have f of minus 3, that's 4.5, and f of 3 is minus 4.5. So the min is minus 3, 4.5, and the max is 3, minus 4.5. So that's all the information we get from f prime of x, and now we're going to go to f double prime of x. Okay, so we want to calculate f double prime of x, so again we're going to take the derivative. Let's just multiply out this numerator over here. And so we have minus x to the 4th plus 9x squared over 3 minus x squared squared. So we'll use this multiplied out form when we do the second derivative. So let's do that. Second derivative. All right, again, quotient rule. Square this denominator, and now we have 3 minus x squared to the 4th. Put this denominator up here, that's 3 minus x squared squared. Derivative of the numerator, minus 4x cubed plus 18x. Minus derivative of the denominator. Okay, here we're going to have to do a chain rule. 2, 3 minus x squared minus 2x times the numerator. Okay, minus x to the 4th plus 9x squared. Now, we're going to do a simplification, dividing top and bottom. Everything is divisible by 3 minus x squared across the top and the denominator. Okay, let's divide this by 3 minus x squared, and that would just bring the exponent down to 3. Here we bring the exponent down to 1. And here we just cross off that factor. Now if we multiply everything out and simplify, this is what we get. Okay, so that's what we get. And we want to put, again, we want to do a plus minus analysis of f double prime, so we're going to put zeros of numerator and denominator on the number line. From the numerator, we just get x equals 0, because x squared plus 9 is never 0. From the denominator, we get x equal plus or minus square root 3. So let's put those on. So we're putting 0 down. We're putting square root 3 again with a open circle, and minus square root 3 again with an open circle. All right, start substituting in. Let's say we substitute in a 2. Okay, the top is positive, and in the denominator we have 3 minus 4 cubed, that's negative. So negative over here. And let's say we substitute in 1. Okay, the top is positive, and here we have 3 minus 1, that's cubed, that's also positive. So positive here. Let's substitute in minus 1, and here we have a negative. And on top, and here we have 3 minus 1, which is positive, so that would be negative. Now let's substitute in minus 2, and here we have negative on top, and 3 minus 4 cubed, that's negative on bottom, so that would be positive. So here the curve is concave down, here it's concave, positive, so that means here the curve is concave up. Negative, concave down, positive up, negative down. Now, one important point is this is the only inflection point. these are not inflection points because they're vertical asymptotes. Even though the concavity changes, vertical asymptotes are not on the graph, so those are not inflection points. So we have an inflection point at 0, f of 0, and that's equal to 0, 0. So that's our inflection point. So now we have all the information, and so all we have left to do is draw the graph. Here we're starting with the f of x information. So let's put in, here we have x-intercept and y-intercept both 0, 0. And the asymptotes root 3 minus root 3, that's about 1.7. So let's say that's 1 and that's 2. So I'm going to put the asymptote about here. And just draw a dotted line coming down. So we're putting in those vertical asymptotes. All right, let's put in that end behavior, and that'll be it for f of x. So we have that it goes down on the right, so it ends up going down here, and it goes up on the left, so it's going to go up here. All right, now let's go over to f prime of x. All right, there's f prime. What we're interested in is this plus minus analysis. We want to put in that min and that max. Okay, so we have a max at 3 minus 4.5. There's 1, 2, 3. And let's say that's minus 4.5. Okay. So that's a max. And then we have a min at minus 3.4, minus 3, 4.5. That's 1, 2, 3, and let's say that's 4.5. So that's a min. So we'll put that in. Okay, now let's see. Here we have our vertical asymptotes. And let's say starting on the right, the curve is going to go up or down here. Well, since this is a max, it seems to me that if we continue this, the curve is going to go down, because here on the right, notice on the right it ends up going down. Let's fill in that end behavior. Let's connect with that. And here it's going down as well. We also have from our f double prime that's concave down here. See, here we have between root 3 and 3, the curve is increasing, so that means it's going like this. All right, so it must be going down there at that asymptote. All right, what about here? Well, from 0 to, well actually we're starting here from from 0 to square root 3, 0 to square root 3, we have that the curve is increasing, so it should be going up. So I would guess that the curve is going up at this asymptote. It's either going to go up or down, but since it's increasing left to right, it must be up. All right, let's look over here at this asymptote. Well, at this side of the square root 3 asymptote here. Okay, what's happening between 0 and minus square root 3? Sorry, that's minus square root 3. Well, the curve is increasing between minus square root 3 and 0. Okay, so if the curve were up here, it would be going down, so it must be increasing like this. It must be going up like that. And over on this side, what's happening to the other side of minus root 3? Well, the curve is decreasing over here. I'm sorry, increasing. Between minus 3 and root 3, we're right here. The curve is increasing. So it looks like it goes up over here. All right, now let's look at the concavity chart, the second derivative, and finish filling this in. So here we have f double prime. Now it says that the curve is concave down to the right of square root 3. Well, that's the way we drew it. That looks good. Now here, between 0 and root 3, the curve is concave up. Here's an inflection point, and here it's concave down. So that would be concave up, go through the inflection point where it changes, and here it does the change to concave down. And on the other side of root 3, the curve is of square root 3, the curve is concave up. So let's end up with that end behavior like we drew before, and let's draw a concave up curve like that. So that's the final curve. So it sort of has everything in it. That's why this is a nice example. It has a maximum point, it has a minimum point, and it has an inflection point, and it has asymptotes. So it pretty much has everything in it.